Alright, welcome to this next set of videos on naming compounds. This one I'm going to focus on naming ionic compounds. Next video we'll talk about naming covalent compounds. Alright, so first just a quick reminder what an ionic compound is. Ionic compounds are made up of one metal and at least one nonmetal. Alright, so that's how we're going to know whether or not the compound we're looking at is an ionic compound. Let's start with an easy one. NaCl. First, look up the metal on the periodic table. And here's my periodic table. There's Na, and it's sodium. It's in group 1, so I don't need any Roman numerals. Group 1 and 2 don't need Roman numerals. And we'll talk about that part in a second. So I'm just going to write the name of the metal. So in this case that's sodium. Look up nonmetal and change ending to IDE. So I look up Cl, and instead of chlorine, I'm going to call it chloride. And that's it, named. Here's a quick list of all the nonmetals and what their endings are going to be for ionic compounds. Now, important to note here is that these are only for compounds only. And I was even nice and I gave you the charge of each of these when they're in a compound. So let's try another one real quick. MgBr2. Alright, so I'm going to follow the same process. I go to my periodic table. Mg, it's in group 2, so I don't need a Roman numeral. And Mg is magnesium. And let's see, where's my nonmetal? Br, so instead of bromine, it's going to be bromide. Real simple. Now, what if I need a Roman numeral? That means, first of all, the metal has multiple possible charges. So this is most transition metals. And these are important because, let's say you go into a stock room and you're looking for iron oxide. And you find one bottle that says it's FeO. And you find a second bottle that says Fe2O3. Which one's the right iron oxide? Well, that's why we need to find the charge of the metal. So, look up nonmetal charge. Oops, let me slide this over a little bit. And I was pretty nice and I gave them all to you right here. Oxides are -2. Set metal to X. And now we're going to multiply down. Remember, if there's no subscript, it's a 1. So -2 times 1 is -2. X times 1 is X. And that gives me a nice little equation here. X minus 2. And now I'm going to set the equation equal to 0. I don't think I need to state this at this point, but we're going to be solving for X. Add 2 to both sides. Plus 2. Move this up a little bit. That means Fe is iron. This is iron 2 oxide. X will equal your Roman numeral. I'll try to squeeze this one in here. We're going to try this one. Same setup. The nonmetal charge is still oxide, so it's still -2. Set the metal to X. Multiply down. -2 times 3 is -6. X times 2 is 2x. Set equal to 0. Now I'm going to solve. I get 2x equals plus 6. X equals plus 3. So this one is iron 3 oxide. And that's all to naming ionic compounds if there's only one metal, one nonmetal. Alright, whoops. What if we have multiple nonmetals? Means there is a polyatomic ion. Now your professor is probably going to give you a full list of all the polyatomic ions he or she is going to use. Here's my list. I'll zoom this out a little bit. Alright, if you want to take this down real quick. So these are the 11 polyatomic ions I could think of that were used pretty commonly. This is by far not an extensive list. This is just one off the top of my head. Now let's say you have something like this. CuOH in parentheses 2. same as before. I'm going to look up the charge of OH, and I see that's hydroxide, OH, and it's -1. Set this one to X, and if I multiply down, I get X minus 2 equals 0, so X equals 2. This is copper, 2, hydroxide. Same process, the only thing that's really changing is where you look up your information. It's also a little bit more complicated, but it's not so much so that it should be an issue. Alright, let's try this one, Fe2SO4 3. Well, I look up SO4, and it's right here, -2, sulfate. Set this one to X. Now when I multiply down, I only multiply by the subscript outside of a parentheses. Alright, so this is -6. This is 2X equals 0. 2X is 6, X is 3. So this is iron 3 sulfate. Be careful if there are no parentheses. Something like this. Alright? I look up NO3. It's nitrate. It's -1. I know we know the charge on sodium. I'm just doing this to continue the trend. When I multiply down now, I have to remember that this 3 is part of nitrate, and it cannot change. So when I multiply down, I only get -1. There's only one of them there. If it helps, throw the whole polyatomic ion in a circle for yourself, and know you can't touch anything inside of there. X times 1 is X, set equal to 0. X is +1. So this is sodium 1 nitrate. Now, another thing real quick. If metal only has one charge, one possible charge, Roman numeral isn't necessary. So I can get rid of that and change it to just sodium nitrate. Alright, last big topic is basically the reverse of this, going from the name to the formula. So this is name to formula. Slow this down a bit. There we go. Calcium bromide. First, write symbols for each. Calcium is Ca, bromide is Br. The ladybug symbol's in the way a bit. Determine charge of each. Calcium we know is +2. Bromide we know is -1. You either look them up on the periodic table or look them up on your list of polyatomic ions. Okay, drop signs and crisscross. So I'm going to get rid of the plus, I'm going to get rid of the minus. We're going to get 2 down there, and the 1 down there. I get Ca1 Br2, which is just Ca Br2. And that's that. Real simple. Let's try another one. Let's try nickel 2 oxide. Same process before. Nickel is Ni, oxide's O. Now determine the charge of each. Oxide we know is -2. The nickel has to be +2. That's what this tells us. Now I'm going to drop the signs and crisscross. So I get Ni2O2, which is NiO. So we're going to go back up to our list and reduce if needed. This is the same way as 2 over 2 equals 1 over 1. And let's try a couple polyatomics before we call it all done. Let's try lithium hydroxide. Lithium is Li, hydroxide's OH, hydroxide's -1, lithium's +1. I drop the signs, crisscross, I get Li1OH1, which is LiOH. Now this next one might be a little tricky. Cobalt 3 sulfate. Alright, cobalt is CO, sulfate is SO4, this one's -2, this one's +3. I'm going to drop the signs, and when I crisscross, pay close attention to how this one's going to be written. CO2, SO4, 3. Remember, can't change subscripts of polyatomic ions. So can't change subscripts. New subscript, outside of parentheses. And that's all to naming ionic compounds. I'll see you in the next one.